Hi, this particular exercise is to show you how to draw free body diagrams for a variety of systems in a proper manner. Knowing just the joints is actually not enough for you to be able to draw free body diagrams. It turns out to be surprisingly hard, no? So what I'm going to try and do is show you some examples so that you can see what the difficulties are and how to do it. Okay. So first example is this wheel which we did in class. I'm going to do that again. So what I want to do is draw a free body diagram of this wheel. So I'm going to cut this out. I'm going to cut this out. Let's see. So first step, draw the circle with the hole cut out. Okay, that's step one. Forget about all the stuff that's inside. Now let us go and look at each place where I have cut. So let us call this point A, point B, point C. Okay, so let's look at point A. It's way up here, and I look at it. When I look at any particular point, I ignore everything else. I ignore rest of the figure. I don't even care about it. So I'm going to look at just this point and I say, what kind of connection is there? Well, is it obvious to you that it's a cable connection? If it's a cable, I'm going to use this. There's the cable connection. So I'm going to say the force here is T1. I don't care how much it is. We will let Newton tell us later. Okay. Then look at point B, which is here, and I'm going to have cut it there. So the force there is T2. I don't even care about the rest. Then at point C is very interesting because this point is actually a axle and it is pins. So the constraint force disallows dislocation of the shoulder. That is, it does not allow either this motion or this motion, but allows spinning. So I'm going to go up here and I'm going to say, okay, this force is necessary to disallow X motion. This force is necessary to disallow Y motion. T1, T2. So it takes care of all of this. Then the last one is the external torque. Can you see this arrow here? I'm going to draw that arrow there. That's the external torque. And many of you would be interested in gravity and so on. If you think that the wheel is very heavy compared to all the other forces, you want to put W wheel. That's my free body diagram. Okay. Let's look at example number 2. This one, I want to draw the free body diagram of this bar. So this creates lots of confusion. So for a lot of people, so I'm going to cut the string here. I'm going to go across. I'm going to remove this joint here. I'm going to go across, remove that joint there, go across, cut this string there. So here is the figure. I don't care what's inside. At point A, there's a pin joint. I don't care about the rest. I will blindly put FAX, FAY, FAX. Then at point F, there's nothing. At point C, there's another pin joint. In later, as we get more experienced, we will start using more detailed and cleverer analysis. Here, we are not going to be clever. We are just going to be systematic. So if it's a pin joint, I'm going to have two forces, FCY, FCX. Notice I don't even care about whether these things are balanced, unbalanced, nothing. I'm just saying blindly pin joint, pin joint, pin joint, that's all. Okay. Then I cut the cable here. So there's a cable force T1. And I cut the cable here, so there's a cable force T2. And that's the end of it. And I'm going to draw my x-axis here. So x direction is like that, y direction is like that. That's it. That's all. Notice I don't care about balance. I don't care about forces not on the outline. What do I mean? I don't care about this one, because as far as the bar goes, the only thing it says is something is pulling on it. It doesn't know it's actually a big box. And I told you that the forces that we encounter are actually sense of touch, not sense of sight. So it doesn't actually see the other forces, it's just there. Okay. So next one, this is an interesting one. So let's see. I'm going to draw for the bar ACB. So I'm going to draw the bar ACB. So there is the bar. This is B. This is C. This is D. Okay, now let's see the joints which we already know. What kind of joint is at C? It's a pin joint. So I'm going to put blindly FCY, FCX. What's the kind of joint at B? Can you see that there's a cable here? So this is FB cable. Those are the joints which we know, right? Now look at the drum. The drum is touching this point and it's like an unpowered wheel. So there is no friction, there is no nothing. So the drum force the kind of joint is called a roller joint or rocker joint. And just to get you an idea, rock and roll are the same in this. Okay, so what happens is this joint is also a rocker. This is also a rocker. For a rocker joint, it's very interesting. It's very simple. I'm just going to draw a force like that. F drum. And then F ground. You see that? Stare at it a little bit. So these two joints are the same as this pin slider. Okay, because how did I know that? You look at that joint. What can it do? It allows the drum to rotate, so there can be no torque. It allows the drum to slide, so there can be no force along that direction. It does not allow the drum to do this, that's why there is a force. That makes sense to you? So this joint by itself allows this. Of course, the total drum depends, what the actual drum does depends upon what the other joints are. But each joint knows only its task and it will just blindly do its task. And that's why it has only one force. Same here. The ground allows this point to move sideways. Yeah, the cable may prevent it, but the ground doesn't. The ground also allows it to rotate around like this. Yeah, the other bars may prevent, but the ground doesn't. Excellent. What I want you to do is look at this figure and draw for me the free body diagram of ACE. The way I want you to do it is pause this video, draw it yourself, and then come and look at what I have. Did you pause the video? Did you draw it by yourself? Yeah, very good. So I will show you. This one is going to look like this. This is ACE. So at point A, again I have FA ground and I have FA cable, and then now I have to decide what I am going to do here. Newton's third law will tell me that this has to be equal and opposite. FCY, FCX. This forms an equal and opposite pair. We'll talk about Newton's third law in a little bit more detail when we get there. But right now I just wanted to show you. And then there is the F drum here. Did you see how this is kind of a mirror image, except for this? This force and this force have to sum to 0. When I put them together, the force vanishes. Okay, this is kind of hard, so stare at it a little bit. Okay, we will come back to these kinds of free body diagrams. I'm just introducing you to the idea. Okay, very good. Now I'm going to go to the next one. This is an actual figure. So this is a trash bin, and I want to be able to draw the free body diagram for it. So my judgment is I'm going to draw side view. Right? In side view, the drum looks like this. Can you see that? Right? And it's resting on this ledge here. And it's a pin joint A. Now let's draw the free body diagram for this. Okay, so I'm going to draw the drum. The center of mass of the drum is somewhere there. That's usually referred to as G. This is the point A and this is the point P. What do you think is happening at A? Pin joint at A. Is that obvious to you? Because here it allows this hinge allows you to rotate it freely like that, but it does not allow either this way. This is not allowed. This is not allowed. Right? So it's a pin joint. So I'm going to put FAY, FAX. What about at point B? It looks as if there's something that's a blunt thing contacting a surface. That's what this point looks like. Right? If it's a blunt thing going on a surface, it's like a rocker joint. It's this guy. What it means is that there will be a force that pushes that way. So we're going to draw that force. F bar. This is hard. You're beginning to get that now. You know, you have to actually make decisions about what is happening in all these things. Okay, and you have to understand that a rocker bar, which is like this, you can see that now, it looks like that. It allows this motion, so no torque. It allows this motion, so no tangential force, but it does not allow this motion. So there is a force that way. That makes sense to you? So let's get back. So here is my drum. That's the drum, or let's see. Yeah, here it is. That's the drum. It allows this motion for the drum. It allows this motion for the drum. But it does not allow the drum to go through. That's why there is only that force which prevents the drum from going through. Very good. Let's look at the next one. Now draw the free body diagrams of all the bars. You think you can do that? I want you to try it, then I will draw it. Okay, so pause it, try it yourself, and then I will draw it. Did you pause? Did you try it yourself? Very good. So I'm now going to draw it. So I'm going to take this thing. So by now you should get the idea, right? So there's a cable that comes out here. Tension in the cable, TG. How much it is, I don't care. It will happen to be equal to the weight of this, but I don't really care. And then at point E, I can draw. That's supposed to be a pin joint, so I can draw. Now I'm going to be a little bit more compact in my notation. I'm just going to call it EY and EX. I'm not even going to put FEY and FEX. Okay, sorry, this is Fy and Fx. And then this is point E, and I'll have Ey, Ex. Now let's look at this bar. This point is the same as that point. So Ex will be like this, Ey will be like that. This is another pin joint, dy, dx. This is yet another pin joint, cy, cx. Get the picture now? Go on drawing. Okay, you can finish this drawing by drawing this base. I'm going to consider this whole thing. And so I'm going to draw that separately here. What kind of a joint is this? Roller. Of course, you can see it's rolling now. So, and it's not powered. So, AY, CY. Sorry, I don't want to call it CY. This is F ground. Why? Because CY is that, right? And then I have something from here. I don't know how much it is. There are two bars. I don't even know what the heck is happening, but I know it's a pin joint. So if it's a pin joint, I'm going to just write it as BY, BX. We will later look at this joint very carefully. This region. Okay, and then there is this point. Notice I have CX and CY. This forms a pair. So I'm going to draw CY, CX because of Newton's third law. And you're wondering, man, that's a clever thing to do. Do I need to be so clever? The answer is no, not really. You can just draw them as two separate forces. And you can use Newton's third law later when you're using Newton's laws. Okay, that's also perfectly fine. But we are going to take a slight shortcut here because we have done this so many times. Okay, let's look at the next figure. Now I am going to draw free body diagram of this guy. By now you should know what to do, right? So please draw it yourself. Pause this video, draw it yourself, and then come back and take a look at it. This is the best way to learn. You know what I mean? You can watch me do it. This is like watching an exercise video. You are not going to build muscles. You want to build muscles? You have to do it. So, did you pause it? Did you draw it by yourself? Very good. So, let's take a look. So, point A, pin at A. Let's see, pin at B. If I call this C and D, I'm going to have cable at C, cable at D. Pin at A. So I'm going to put AY, AX. Pin at B, BY, BX. Cable at C and D. So all the stuff, there's a bump here, and there are these two things, TC, TD. Done. I did not care about gravity, it's not that important. Also, we are trying to make sure we learn how to do the constraint forces. This is the hard part. So please, practice more and more and more. You will get better and better and better. That's all. So for each kind of joint, you have to make the decision what kind of joint it is and which among these things to use and how to use it. So what kind of joint? . 1, 2. How to use it? Those are the two things you have to be able to answer. Okay, let's try another problem. This is interesting. I'm going to draw this foot pedal. Can you see that pedal here, this thing? Okay, can you see it's pinned here, and there's a spring, and then there's a bar here. So I'm going to draw this thing. Okay, that's my bar. So notice this is like a cable. So I'm going to draw cable at A. How do you know it's like a cable? Can you see this long thread like thing going? I'm thinking that's like a cable. Look at this spring. That can only pull. You know what I mean? So there's a cable at C. Let's call this point C. What about point A? Pin at A. This is the high level decision. If I do that, I'm going to have, cable at B. A cable at B, TB. Cable at C, TC. This is from the spring. And then pin at A, FAY, FAX, and then motive force here, F or P. This is the motive force. That's what all these other things are constraint forces. Okay, very good. Let's do another one. This is an interesting one. I want to draw the free body diagram of the bar. Again, the best way to learn, pause it, you draw it, and then I'll compare, and then we can see. So let's do that. Did you pause it? Did you draw it yourself? Hey, if you want to learn, you have to be wrong once in a while. So don't be afraid to draw something which is utterly wrong. You know, don't worry about it. Nobody is looking at you. You know what I mean? If somebody is looking at you, go sit in the closet and do it in secret. But whatever you do, try your own thing at it, and then then look at my answer. If you just look at my answer, it will look kind of easy. It's only when you try it and you have to make the decision, then you have to worry. Okay, very good. So let's see. Point A, it tells you even what is the force. So that's easy, 250 newtons. How about point C? Well, what kind of a joint is it? Do I think it's a welded joint? No. Because it allows this thing to go like that. So it cannot be a welded joint. What about a pure sliding joint? Yeah, it looks like it's sliding. It can slide. I mean, forget about these things. I'm just looking at if this was the only one that's present, it can slide. It can rock back and forth. You see what I mean? You know where I'm headed, right? It's not a slider joint. It's not a pin joint. It's close to a pin joint, but it's not because it allows it to move, slide. It's this pin slider. So pin slider, force is perpendicular to the contacting surface. Contacting surface is this. Force is like that. I don't care which way you put. C. How about point B? Did you see? It's not this, it's not this, it's not this, it's that, it's not that. Why? Because it can slide back and forth like that, and it allows you to rotate like that. Right? So there's the pin, there's the slider. That's why it's called a pin slider. And a pin slider, the force is perpendicular to the contact surface. Contact surface is that. The force is perpendicular, so it has to look like that. B. What about point A? If point A were the only joint that was present, it will allow me to slide this way and it will allow me to rotate like that. So it's also a pin slider. So I'm going to put A like that because this is the surface of contact. So pin sliders equal to roller equal to rocker, all these things are the same, allows body to rock and roll. You know what I mean, right? Rock and roll and slide. So it allows that and that. And this way is forbidden. Got it, right? Excellent. Let's look at the next one. I'm going to draw the free body diagram of this guy. So here goes, and you know what to do, right? Try your hand at it. Can you see the slot here? That's very important. Okay, so let's see. There's the 100 Newton force. What about point B here? What kind of joint do you think it is? If that's the only joint that was there, what will happen to this object or to this object, to our object? Can you see it allows the object to rotate and slide. So it's a pin slider at B. So the force is going to be like that. How about point A? Now there's some decision to make, because if it looks like this, right, if this thing looks like that, then you can say, look, it's allowing me to move sideways very nicely. It's preventing this motion. That motion is prevented. It allows me to rotate. So this is a pin slider also, which means my force will be like this. What about the other piece? First, notice this is exactly the same as that. So I'll have a force B, and this is exactly equal and opposite to that. So I'll have a force, if it is like that, it's going to be like that. FB, FA. And then I have force 100 newtons. This is because of Newton's third law. You don't have to do it. You can draw a separate force, but then you'll have to recognize basically that this is a pin and slider. That's all. So basic idea is pin slider here, which is equal to rock and roller. So it's got to be a rocker and roller. This is the first one in which we have friction. So let's draw the force for this guy. So block. That's easy. Tension. This is a slider. Can you see that? So I'll have normal force, bending moment or moment M there, and also friction force. So friction resists sliding. So if there was no friction, is it obvious to you that it's going to slide that way? So friction force is going to oppose that. This is F friction. How about for the wheel? Tension P. Now notice this is a powered wheel. Okay, for a powered wheel, it's not just this normal force. If it is an unpowered wheel, that's all. This will just be a roller. It's a powered wheel. Imagine what will happen if this thing were fixed. If I fix this and I pull here and there is no friction, what will happen? Is it obvious to you that it's going to start turning like that? So the sliding is going to be backwards, right? Friction will stop that by preventing it from sliding backwards. So the friction force for this is going to be forwards. This is F friction 1, that's F friction 2, because they are not equal. And this one is going to be, friction force is going to be forwards. Isn't that bizarre? Think about it very carefully and you will see whether it's reasonable or not. We'll have a discussion about it, but this is very tricky. Okay, so I've shown you a whole bunch of free body diagrams. What I would want you to do is play this thing again and again to see what decisions I made. Okay, there's lots of decisions here and some of them you may agree with, some of them you may question. If you question, good, because that's how you will understand. So question and ask me in class or at the tutorial session and we'll see what happens. Okay, thank you very much.